Hello everyone. At this part, we are going to introduce another technology that can improve the stability of the network. It's called the virtual AC. Virtual AC is a network system virtualization technology that combines multiple ACs into one virtual device. Multiple ACs of the same model can form a VAC system. In this figure, you can see we have AC1, AC2, and AC3. And after using virtual AC, actually they can form a VAC system. And logically, you can think that we only have one AC in the network. So it can simplify the network topology and reduce the network management and the maintenance costs, shortens the application recovery time and service interruption time, improves network resource utilization. Okay, so about this technology, let's see the mechanism of it. The active AC controls the entire VC system, runs the management plan protocols, runs its own control plan protocols, and participates in data forwarding. Except that the backup or the standby AC runs its own control plan protocols, participates in data forwarding, and takes over the role of the active AC when the active AC is faulty. And when the standby AC malfunctions, the candidate AC takes over the role of the standby AC, and the candidate AC cannot take over the role of the active AC. Therefore, when the active and standby ACs malfunction at the same time, the VC system will restart. And control plan protocols are mostly backup among the ACs. So from what we have just said, you know that if the AC1, which is active AC, is 40, so AC2 will be the new active, and AC3 will be the new backup. Okay, and it's impossible for the AC3 to be the new active AC directly. Okay, this is about the mechanism of the virtual AC. And since we have introduced the active AC, the backup AC, the candidate AC, so how do we elect the rules in the network? Of course, we should know some parameters, right? A VAC system can be considered as a domain. So each VAC system has a unique domain ID, and only the ACs with the same domain ID can form a VAC system. And to distinguish the ACs in one VAC system, each of them will get a unique AC ID. Okay, and it's used for AC management. When adding an AC to a VAC system, you need to configure ID for the AC and ensure that it is unique in the whole domain. Okay, and the next will be the election mechanism. To elect the active AC, firstly, we prefer the AC that complete the startup process first. And during the startup, none of the ACs is active AC anymore. And if the AC starts or finishes the startup process first, it will become the active one. Okay, but if the active AC cannot be determined according to the preceding rule, the AC with the highest priority. So the second place is the highest priority becomes the active AC. While if the active AC cannot be determined according to the preceding rules, so AC with the smallest ID will become the active AC. And for the standby AC, firstly, we will compare the ID of the switch connected to the active AC. So the ID of the switch is considered first. The AC that does not reside on the same AC as the active AC will be preferred to be the standby AC first. Because if the standby AC and the active AC connect to the same switch, and once the switch is faulty, the whole system will be restarted. So we prefer the standby AC not connected to the CM switch with the active one. And if there are multiple ACs that do not reside on the CM switch as the active AC, so the AC with the highest priority becomes a standby. While if the standby AC cannot be determined according to the preceding rules, AC with the smallest ID will be preferred. So actually, during the election, we prefer the AC finish the startup process first, and then the priority, and then the smallest ID. While for the standby AC, we prefer the ACs not connected to the CM switch with the active AC, right? And then highest priority, and then smallest ID. Okay, this is about the rural election, and then let's see some basic configurations of the virtual AC. You can see here, virtual AC domain 100. So we have created a virtual AC domain, and the domain ID is 100. Then device 1. So we have specified the, for example, this device ID is 1. And device 1 priority is 200. So the priority of this device is 200. And next, VAC ports. By using this command, we can specify the, for example, gigabit Ethernet 01 and the gigabit Ethernet 02 to be the VAC port on this device. Okay, this is about the configuration on AC1, and on AC2 actually is similar, right? The domain ID must be the same 200, and the device ID is 2, priority is 200, and the VAC port is 01 and 02. It's similar to what we have configured on AC1, right? Okay, and after finishing the configuration, we can see the commands here, and you can verify the results. Okay, this is about the VAC technology. We have introduced the function of it, the working mechanism of it, and the basic configuration of it. And of course, based on the commands here, we cannot finish the entire configuration of the VAC technology, but here is the most important part. Okay, and then at last, let's see the question. If the active AC is 40, which AC will become the new active one? Choose A, candidate AC, B, slave AC, C, backup AC. So which one do you think will be the new active AC? Actually, C, the backup AC will be the new active AC. Okay, that's all for this part.